The formula for the volume of a cone is V is equal to 1/3 pi r squared h. Assume you are holding a 6-inch high sugar cone for ice cream. A. Construct a function V of r for the volume as a function of r. We start off with the formula V is equal to 1/3 pi r squared h, where r is the radius of the base of the cone and h is the height of the cone. Notice that in this formula, volume is a function of both the radius and the height. However, we're given that the height of this cone is 6 inches. Therefore, we can write the volume in terms of r alone. We just substitute 6 for h. We get 1/3 pi r squared times 6. Well, 1/3 times 6 is 2, so our end result is that V is equal to 2 pi r squared. Therefore, V of r is equal to 2 pi r squared. Next, we're asked to find V of 1.5 and explain what you have found. To find V of 1.5, we substitute 1.5 for r in the formula. We get 2 pi times the square of 1.5. Using a calculator, we get approximately 14. So what have we found? Well, assuming that the radius is 1.5 inches, we've determined that the volume of the cone is approximately 14 cubic inches. Notice that if we substitute inches for h and inches for the radius, we get inches squared times inches, which is cubic inches. Let's move on to part B. When dealing with abstract functions where f of x is equal to y, we have sometimes used the convention of using x rather than y as the input to the inverse function f inverse of x. Explain why it does not make sense to interchange v and r here to find the inverse function. Let's first of all review the steps for finding the inverse of a function. To find a formula for V inverse, we would need to perform the following steps. Step number 1, we would verify that V is a one-to-one function. Our volume function V is given by the formula V of r is equal to 2 pi r squared. Notice that because r is squared, V is a quadratic function. The graph of a quadratic function is a parabola. So at first glance, it would seem that the volume is not a one-to-one function because a parabola does not pass the horizontal line test. However, this is an application. We know that the base radius of the cone has to be positive, so we can specify that r must be greater than 0. Therefore, the graph of V will be not a whole parabola, but just the right half of the parabola. And the right half of the parabola will pass the horizontal line test, and therefore V is one-to-one. Therefore, we move on to step number 2. Step number 2 would say, solve the equation V is equal to V of r for r, obtaining the equation r is equal to V inverse of V. We start off with V is equal to V of r. The notation is a little bit confusing because we're using the letter V for the name of the function as well as for the dependent variable. But we know that V of r is equal to 2 pi r squared, so we make that substitution. We get V is equal to 2 pi r squared. We need to solve this equation for r, remembering that r is a positive number. So first of all, we would divide both sides by 2 pi. That gives us V over 2 pi is equal to r squared. In order to undo squaring, we would take the square root of both sides. Now V over 2 pi, that's a positive value, so it's going to have two square roots, one positive and one negative. But we know that r is positive, so we're going to only keep the positive square root. We get r is equal to the positive square root of V over 2 pi. Now notice originally we started off with V is a function of r, but now that we've solved for r, we have r is a function of V. And the name of this new function is V inverse. So R is equal to V inverse of V. Step 3 says to interchange the independent and dependent variable. In this case, that would be interchange the R and the V. However, in part B, we're asked to explain why it doesn't make sense to do that in this case. Well, let's see what would happen if we interchange the V and the R. We would get the new equation, the square root of R over 2 pi is equal to V. However, in this application, R and V have specific meanings. R is the radius and V is the volume. We already know that the volume is given by the formula 2 pi r squared. So by interchanging the V and the R, we end up with an incorrect formula. This formula is not correct. So in this particular application, we would most likely indicate the inverse function as R of V is equal to the square root of V over 2 pi. The volume function V gives us the volume as a function of the radius, and the inverse function gives us the radius as a function of the volume.